Hi everyone. In this video, we are going to discuss about some problems associated with the normal distribution. So here I have given a question and that question is like this. X follows normal with a mean 42 and variance 16 or standard deviation is equal to 4. Then find the following probabilities. The first one is probability that a value x is less than 50. So I'm going to take that first question and that is probability of x less than 50. So I can write that as probability of x less than 50 in probability notation. So before going to this, what we are going to do is, we know x follows normal with mean 42 and standard deviation 4. So what we are going to do is, we are going to standardize it. So standardize it using x minus mu by sigma. Since mu is 42 and standard deviation is 4, we can write z is equal to x minus 42 divided by 4. And z is a standard normal random variable. So, what we are going to do is, we know probability of x less than 50 is equal to probability of x minus 42 divided by 4 less than 50 minus 42 divided by 4. Isn't it? Yes. This is equal to probability of, I can write x minus 42 by 4 as z, where z less than 50 minus 42 is 8 and 8 by 4 is 2. So, probability of z less than 2. But using the standard normal table, we only know to find this z alpha such that this area is alpha. And this was probability of z greater than z alpha was equal to alpha. But the probability that we have to find here is probability of z less than 2. So in order to find this, there are two methods. One is to find 1 minus probability of z greater than 2. So probability of z greater than 2 can be found from the standard normal table, which is equal to 1 minus 0.0228. Which is equal to 0.9772. So this is one method of finding this probability of x less than 50. Now another method is to find this is equal to probability of minus infinity less than z less than 0 plus probability of 0 less than z less than 2. So, we can find this probability as a sum from here to here. So, the easy method is to find from the standard normal table, and from the standard normal table we can find probability of z greater than 2, and in a similar way we can find this. Now the second question is probability that x takes values greater than 50. So to find the values x takes greater than 50, that is equal to probability of x greater than 50, which on standardizing we will get x minus 42 divided by 4 is greater than 50 minus 42 divided by 4, which is equal to probability of z greater than 50 minus 42 is 8 by 4, which is probability of z greater than 2. And as an answer to the previous subsection, we have found probability of z greater than 2 and which was equal to 0.0228. This is this probability. Similarly, the third question is probability that x takes values less than 40. So to find that, we take probability of x less than 40, which on standardization we will get x minus 42 divided by 4 is less than 40 minus 42 divided by 4, which is equal to probability of z less than 40 minus 42, which is equal to minus 2 divided by 4, which is probability of z less than 1 by 2, minus 1 by 2, which is probability of z less than minus 0.5. So, z less than minus 0.5 can be written as 1 minus probability of z greater than minus 0.5. Isn't it? Yes. So this is equal to 1 minus probability of minus 0.5 less than z less than 0 plus probability of 0 less than z less than infinity. We know this value is probability of z greater than 0 and which is equal to 0.5. Now what we require is to find this. So that is minus 0.5 is somewhere here and we are required to find this area. So in order to find this area, what we do is, in order to find this probability or in order to find this area, it is equivalent to find this area. Why? Because this curve is symmetric about z is equal to 0. So, for me to find this minus 0.5, I can find a value from 0 to this value. So, this is equal to 0.5. So, this is equal to, what is it? This is equal to 0.5 minus, that is the total probability minus the probability that z greater than 0.5. The probability that z greater than 0.5 is, this value is 0.3085. Therefore, this corresponding area is 0.5 minus 0.3085. Therefore, this small area is also the same, which is equal to something approximately equal to 0.2. Isn't it? Yes. This is something related to 0.2. So, this probability was something related to 0.2 and this is 0.5. Therefore, 1 minus 0.7 will yield us something that is equal to 0.3. So, another simple method to do this is, we know probability of z less than minus 0.5, and we do have a normal curve, and this is z is equal to 0, and this is minus infinity, and this is plus infinity. So z less than minus 0.5, I suppose this is minus 0.5. So z less than minus 0.5 means it is this area. It is this area. So it is this area, and this curve is symmetric about z is equal to 0. This area is equivalent to z is equal to my 0.5 and this area. So I can find the probability corresponding to this, and the probability corresponding to this area is 0.3085. Therefore, probability of z less than minus 0.5 is also 0.3085. Why? Because the normal curve is symmetric about z is equal to 0. Since it is symmetric, to find a value here, it is enough to find the same area here. Now the fourth subsection is to find the probability that a value x takes value greater than 40. So probability of x greater than 40. So what we do is we are going to standardize it. So x minus 42 divided by 4 is greater than 40 minus 42 divided by 4, which is equal to probability of z greater than 40 minus 42 is minus 2 divided by 4, which is equal to minus 1 by 2. So what we need is probability of z greater than 1 by 2, which is equal to probability of z greater than 0.5 minus 0.5. So we shall mark this point on the normal curve. This is z is equal to 0, and what I need is z greater than minus 0.5. So this is minus 0.5, and z greater than minus 0.5 means this is the area to be found. Yes. So we have already found what was probability of z less than minus 0.5, which was, we have already found this value, which is equal to 0.3085. So since we know this value, we can directly write it as 1 minus 0.3085, and that will be this probability. Or else what we have to do is we have to find this area and add it to 0.5. So that also will yield us this corresponding the required probability for probability of x greater than 40. Now, another part of the question is to find the probability that a value x is between 43 and 45. So, what we have to do is, we have to find a x such that it is between 43 and 45. So, 43 less than x less than 45, which is equal to probability of 43 minus 42 less than x minus 42 less than 45 minus 42, which is equal to probability of 43 minus 42 divided by 4 less than x minus 42 divided by 4 less than 45 minus 42 divided by 4. So this is equal to probability of 43 minus 42 is 1 by 4, isn't it? Yes, it is 1 by 4 less than z less than 45 minus 42, that is 3 by 4. So this is equal to probability of 0.25 less than z less than 0.75. So I can write this as probability of z greater than 0.25 minus probability of z greater than 0.75. I can write this because from the normal curve, if I mark 0.25, suppose this 0.25 is here, and I have to mark this 0.75 here, this is my required area. But probability of z greater than 0.25 will give me the total area from here till here. From that, if I subtract probability of z greater than 0.75, so it subtracts this area. So I'll get this area between 0.25 and 0.75. And these values can be found from the standard normal table, which is equal to 0.4013 minus probability of z greater than 0.75, which is equal to 0.2266. So this is the required answer for the probability between 43 and 45, which is equal to 0.1747. So this is the required probability for x lying between 43 and 45. Now what we have to find is, we have to find the probability that a value x is between 37 and 41. So as in the previous case, what we are going to do is, we are going to write 37 less than x less than 41, which is equal to probability of 37 minus 42 divided by 4 less than x minus 42 divided by 4, which is less than 41 minus 42 divided by 4. So this is equal to 37 minus 42 is, what is it? It is minus 5 by 4 less than z less than 41 minus 42 is minus 1 by 4. Which is equal to probability of minus 1.25 less than z less than minus 0.25. So if we draw the standard normal curve, we can mark this area as minus 1.25 and this is minus 0.25. So this is the required area. So in order to find this required area, we can take the reflection of this area to this side. So what will that be? That will be where this is equal to 0.25 and this is equal to 1.25. Since this normal curve is symmetric about z is equal to 0, this area is equal to this area. We know to find an area in the right side where it is equal to probability of z greater than 0.25 minus probability of z greater than 1.25. So this is equal to z greater than 0.25 is 0.4013 from the standard normal table, and z greater than 1.25 is equal to 0.1056. So this area is equal to this subtracted from this. This subtracted from 4013, 0.4013, which is equal to 0.2957. So this area is 0.2957. Therefore, this area is also 0.2957. Therefore, we can use standard normal table and the standard normal distribution, and if any x is given, we can standardize it and use this table and this distribution and its properties to find the probabilities of any x with any mean and any standard deviation where x follows normal distribution. I hope this video was useful. Thank you.